Greetings and welcome to this edition of Pharmacy Focus at the University of Charleston's School of Pharmacy. This episode is surely going to be a treat as you hear from two of our faculty members here in the School of Pharmacy about the research and some recent grants that they were awarded and the opportunity for students to interact in the lab and learn lots of great and interesting information. So sit back, relax, and I hope you enjoy this edition of Pharmacy Focus. Welcome, Drs. Linger, Becky Linger, and Dr. Aymen Shatnawi. We really appreciate you taking some time to talk to us about some exciting news that has just occurred for the two of you. My understanding is you all have received some dinero, some monies associated with your proposals from West Virginia Embry. And so, Becky, why don't you tell me what West Virginia Embry is all about?
Okay. Well, West Virginia Embry is a program that is administered by the NIH, and it's a funding entity that will allow underrepresented states in the research environment to have a source of money that is not as competitive as a regular NIH grant, an R01 or an R15. INBRE stands for Idea Network for Biomedical Research Excellence, which also indicates that there's a stipulation that the proposals need to be of a biomedical relevance. But West Virginia has been participating in the NIH INBRE program for over 10 years. I believe it's been probably 14 years now. And from the time that I started as a faculty member here at the UCSOP, I've received over $100,000 in funding from the WV Embry. So I'm very grateful to the program for allowing me to do my research here at UC.
And so the latest grant that you received, talk to us a little bit about that project and what that's all about.
Okay. Well, West Virginia Embry is a program that is administered by the NIH, and it's a funding entity that will allow underrepresented states in the research environment to have a source of money that is not as competitive as a regular NIH grant, an R01 or an R15. INBRE stands for Idea Network for Biomedical Research Excellence, which also indicates that there's a stipulation that the proposals need to be of a biomedical relevance. But West Virginia has been participating in the NIH INBRE program for over 10 years. I believe it's been probably 14 years now. And from the time that I started as a faculty member here at the UCSOP, I've received over $100,000 in funding from the WV Embry. So I'm very grateful to the program for allowing me to do my research here at UC.
Okay, so the latest grant that you received, talk to us a little bit about that project and what that's all about.
So the grant that will be funding me for 2016 and 2017 is related to a question of cancer relevance. And what I'm doing is I'm collaborating with a small research laboratory in Indianapolis who is developing small molecules from a natural product, and that's actinomycetes, which is a few years ago was classified as a fungus because it's a filamentous organism. But further study of the actinomycetes determined that it actually is a bacterium. And so what they're doing is they're challenging this organism to create inhibitors to glutamine biosynthesis. What does glutamine biosynthesis have to do with cancer? One of the things that a cancer tumor can do is, as it grows, it will outgrow its blood supply. And in the interstitial fluid of our bodies are a lot of amino acids. And glutamine can easily be transformed into the energy intermediates that are used in the Krebs cycle. And so what the cancer cell does is it starts to switch from using glucose as an energy source to glutamine as an energy source. There's been a lot of study recently about what cancer types are doing this, and it seems to be mostly solid tumor cancers are developing that, and that sort of makes sense. As that solid tumor starts to grow, we see sometimes that the center of it becomes necrotic because it's outgrown its blood supply. And so how is it able to stay alive enough to divide and continue to grow? And they determined, oh, well, it's getting a new source from glutamine. So we have these small molecules that are coming to us from Indy, and what we're going to do is we're going to assay their activity against the specific enzymes of glutamine biosynthesis. So we'll look against glutamine synthetase. Are they preventing the cell from making glutamine? Because once you've utilized glutamine as an energy source, you can regenerate it with enzymes in the system. Maybe it's inhibiting glutamate dehydrogenase, which is a major player in the final step to get into the Krebs cycle, because the product of glutamate dehydrogenase is alpha-ketoglutarate. And so all of my students who have had biochemistry know that alpha-ketoglutarate is an intermediate in the Krebs cycle. So it's a really interesting basic science project, but it really has direct application to what the students are learning in the classroom. And I think that students are going to be really, really engaged with that.
Wonderful, wonderful. Thank you for sharing that information. So, Aymen, tell me a little bit about your project that was funded.
The recent project, first of all, I would like Embry for their support. And it's very important for us as a researcher to, especially at University of Charleston, to let the student be engaged and get some idea about the bench research, which is a very important thing for the pharmacists. My research mainly focuses on prostate cancer. So what we are trying to do is trying to identify certain proteins that are involved in the development and progression of prostate cancer. So we have, I have collaboration with other institutions, such as Duke University, Marshall University, and West Virginia State University. So we are doing a project. We are doing a project that, by investigating certain cofactors that are involved in the androgen receptor regulation, understanding the mechanism by which these regulators would lead us to identify certain or design certain pharmaceuticals compound that will be definitely used to disrupt this interaction, and it would be part of the cancer treatment. The problem with prostate cancer mainly is at the beginning it's easy to be treated because it's hormone sensitive. So what you do is using anti-androgenic compounds. Now 5 years later, like the prostate cancer progressed to a stage which is like we call it hormone refractory stage, a stage with like the tumor itself become resistant to the treatment. So we are also trying to understand why the tumor is progressing from a hormone sensitive stage to a hormone resistant state. There are so many theories now. However, we took one of these and we are trying to focus on it and identify the exact mechanism of that.
Wonderful, wonderful. What I heard from both of you as you were describing your projects were some similarities. One, of course, cancer is the backdrop of both of you, of your proposals for research study, but then I heard about the collaboration.
Yes.
And so it sounds like that key in research is that you need to collaborate, right? You need to have the opportunity to work with other individuals with certain expertise and certain equipment and other things like that to help make the whole project go. And then the other thing that I heard in similarity was the part about students, right? And the opportunity for students to see the relevancy of the research into how they're going to actually be treating patients. So with both of you, I know that you all have been doing research prior to this grant proposal and its awarding, but talk to me a little bit about students in your labs. How does that process work, and what do the students gain from that? Either one of you, whoever wants to answer that.
Well, since the beginning of my tenure here at UC, I've had students in the lab, and primarily what happens is that students will learn that I'm doing research and come and contact me. And I'll take all comers. You know, if they're interested, I'll bring them in, and we'll see how they handle it. And I've had some pretty good success over the years. But a student that works in my lab, they won't just be a bottle washer. I actually had a P1 student ask me today, I'd like to work in your lab, but what exactly would I be doing? I said, hey, you're going to be doing the assays and you're going to be doing everything. My goal is to train them to be able to perform the experiments flawlessly, but also to start thinking about where do we go from here? If this didn't work, what do we need to change? So I'm trying to get them to think like scientists. I operate with good laboratory practices from the very start. There are certain things that students have to understand that have to be done in the laboratory and ways that you conduct yourself. But over the years, the 10 years that I've been here, I've had over 30 students come through my laboratory. And so with the Embry grant, we do have a stipend for students. And so I'm able to pay $10 an hour to up to 3 students with my grant.
Wonderful,
Yeah.
wonderful.
The same thing with me also. Yeah.
So I think the value and the benefit for the students really is for them to increase their skill sets in terms of their ability to really demonstrate a different way of thinking through situations and scenarios, but also the meticulous and care that needs to be taken when they are conducting these experiments, and recognizing that one small mistake here has long-term implications on the other parts of your experiments. So wonderful information that you shared with us. It's exciting to know that we have 2 of our members of the Department of Pharmaceutical and Administrative Sciences here to really share with our audience a little bit of your passions as it relates to your research areas, and who knows what's next, right? Pharmacy Focus today may be on evening news the next day, right? Talking about some of the positive outcomes of your efforts and your ability to also expose students to greater and bigger things. So thank you so much for being here. We're very proud of your accomplishments and we appreciate you.